We're back again.
Question 3 now.
Absolutely.
We're still on the same paper.
Absolutely. January 2008, AQA. And it's a third question, so here we go.
So it doesn't say anything in the intro, it just goes straight to part A.
It does.
So what we've got is 5 root 8 plus 6 over root 2, and it says to express that in the form n lots of root 2.
So what we want to do there is we want to get them in the same form. That's not a root 2.
And that's on the denominator, you don't want that either.
You don't want that either. So, get rid of each one first, doesn't really matter which way you do it.
No, I think we should just start with this way, just to go in the order from left to right.
I think we should. So that can be simplified.
Yes, and we have rules on this in our surds chapter. You should check that out if you don't know what you're doing.
Yep. But that could equal root AB.
Root AB, yeah.
And the A and B could be 4 and 2?
Yep, in fact, that's all it could be. Unless you want 1 and 8, and that wouldn't help you.
It would not.
Because, just to clarify, root 4 times root 2 is the same as saying root 8. That's why you can do it.
That's why you can do it. So then we'll have 5 lots of 4 times 2, but because 4 has a root, that becomes on the outside of the thing, which times the 5 by 2, so it becomes 10 lots of root 2.
It's the same as 2 root 2. If you've got 5 times that, it becomes 10 root 2, as Triv said.
It does. Then we have a plus 6 root 2, which you also don't really like.
Yes, and we never want surds on the denominator. On the numerator is okay, and in this case, it should boil down to no fraction at all.
Yep, so that's the plan. And there's a way of doing this one, isn't there?
There is indeed. You times both the numerator and the denominator by the surd involved,
Yeah.
and it will cancel the surd because root A times root A is A.
It is. So if we times both the top and the bottom by root 2 times root 2 is 2, as Wayne said, and 6 times root 2 is 6 root 2. So that changes to 6 lots of root 2 over 2, which is the same as 3 lots of root 2.
Yes, it's the 6 and the 2 divide. You've got 10 root 2 plus what's going to become 3 root 2. Now, because the root 2's are the same, you can add the coefficients of the roots. So this becomes 13 root 2. If the roots were different, if this was root 2 and this was root 3, you couldn't add them together, just to clarify. And that's the answer.
And that is the answer, because it wants to form n root 2, and that's Rn.
Yep, simple.
Done.
So, we'll take a step back and have a look at that.
No, should be long enough.
Should have been long enough. We pause
Okay,
it. So we've now got B. We've got a much bigger thing to deal with, and it boils down to C root 2 plus D. So it says to express root 2 plus 2 over 3 root 2 minus 4 in that form. So at the end you're going to have no fraction and a root 2 and a constant.
Essentially what you're doing here is rationalising the denominator. Again, we have a video on this if you're really struggling, but we'll go through it now.
Yep. So what you do is you take your initial, what is a fraction, it's quite a complex fraction, but it's a fraction, root 2 plus 2 over 3 root 2 minus 4. Now because this root 2 is on the bottom, you want to get rid of it. You always want to get rid of surds that are on the denominator. But if you times by just root 2 again, that wouldn't work. You'd end up with, that would cancel, but then you'd have minus 4 root 2. So you'd just be back in the same predicament. So what Triv's done here is he's times by the conjugate pair. You see this minus, it's been flipped for a plus. It's called the conjugate pair. And you do the same to the top as you do to the bottom, always.
If you're good at expanding brackets, you'll notice there'll be a difference of 2 squares here, and that's why you do it.
Yep. So rather than timesing that by that and then that by that, you can just ignore the middle steps and times first by first and last times last.
And that's all you need to do. So I'm going to call the top part A and the bottom part B,
Okay.
and I'm going to do them separately.
That's a good idea. It's a good idea.
So, I haven't got a huge amount of space, I'll do it here in blue. There's your of colours. So our A I'll do first.
So that's the top. You've got root 2 plus 2 times 3 root 2 plus 4. So you want to times your inners together and your outers together, inner by outer and outer by inner. You want to times everything by everything.
So, root 2 times 3 root 2 is, well,
3
6.
times 2, which is 6, because the root 2 times root 2 just becomes 2, and that's still times by 3.
It is. Then root 2 times 4 is 4 lots of root 2.
Yep, the 4 becomes the coefficient of the root. Same thing here, except the 2 times by 3 is the coefficient.
So it becomes 6.
6 root 2. And then you've got 2 times 4, which is 8.
That all boils down to 14
That's
plus
8 plus 6.
10 root 2.
4 root 2 plus 10 root 2.
Okay, now we've done that, we'll do part B. So you want to move up a bit, Wayne? I'll do it that end.
Want to swap places?
Do that too, that works well.
So, B is 3 root 2 minus 4 times 3 root 2 plus 4. And what we said is you can just do the inners and the outers. That's what you can do with conjugate pairs. So you're going to have 3 root 2 times 3 root 2 and minus 4 times 4. Be careful of your pluses and minuses. Conjugate pairs are always opposite, so just be aware of that.
So we get 18.
Yep, because 3 times 3 is 9, root 2 times root 2 is 2, 9 times 2 is 18.
Minus 16, which equals
Minus 4 and 4.
2.
And that'll be your denominator.
It will be. So if we grab out the top bit here,
Do you mind if I use your purple?
that's quite right. Then you were right up the bit nicer fraction up there.
Right, so
So A, which is on the top, we have 14 plus 10 lots of root 2.
10 lots of root 2. And then on the
Below that we have just 2.
So it boils down to
We don't want a fraction on the bottom, so we just divide everything by 2. That's what that's doing.
14 over 2,
Which is 7. And 10 lots of root 2 over 2 is just 5 lots of root 2. So that is our end. And now we'll do a different order, but it doesn't really matter as long as we say where C and D are.
Yep.
And that's your question.
And there we go, that's question 3. We'll see you at question 4 of this same paper.
Absolutely.
Let's crack on.
Roll.